Welcome! In this video, we'll break down the Vertex AI RAG engine, a managed retrieval and grounding framework for Gemini. We'll explore how it connects enterprise data to large language models and help solve key challenges like hallucinations, limited context, and outdated model knowledge. Let's dive in. At its core, Vertex AI RAG engine is a managed retrieval framework that connects Gemini to private enterprise data sources via retrieval and grounding. The problem: large language models like Gemini are trained on general-purpose data and have limited awareness of private enterprise data, frequently changing information, domain-specific knowledge. This can lead to incomplete, outdated, or hallucinated responses. The solution: the RAG engine enables retrieval-augmented generation by retrieving relevant information from external enterprise data sources during inference. It then injects this information as grounded context into the model at runtime. This improves factual accuracy, contextual relevance, and reduction of hallucinations. Instead of relying only on static training data, Gemini dynamically retrieves and uses enterprise knowledge to generate grounded responses.
The Vertex AI RAG engine ingestion system is more than file upload. It is a structured transformation and indexing pipeline that prepares raw enterprise data for retrieval at query time. Connectors. The system supports ingestion from core enterprise sources, including Google Cloud Storage, GCS, Google Drive, direct file uploads. These sources bring external data into the RAG pipeline for processing and indexing. Parsing layer. After ingestion, documents are processed using parsing strategies based on structure and complexity. Default parser. A general-purpose parser for standard documents, such as PDFs and text files. It extracts raw content efficiently. Layout parser, document AI-powered. Extracts structured elements such as headings, tables, and lists, preserving document structure for more accurate retrieval context. LLM parser, Gemini-powered. Uses a language model to extract deeper semantic meaning from unstructured content, enabling richer contextual understanding. Deduplication. During re-imports, the system can detect unchanged files and skip redundant processing. This improves ingestion efficiency and helps reduce unnecessary embedding and indexing costs. Chunking. Documents are split into smaller chunks as part of the transformation pipeline before embedding and indexing. Chunking is configurable and helps balance retrieval precision, contextual completeness. Key system principle. Ingestion is not retrieval. It is a transformation and indexing pipeline that prepares data so it can be efficiently retrieved at inference time. Operational considerations. Ingestion is asynchronous and depends on correct service account permissions. Misconfigurations can result in ingestion failures. It also triggers downstream processes such as embedding generation, which contributes to overall system cost. The ingestion engine transforms raw enterprise data into structured, indexed representations so Gemini can retrieve it accurately during generation. Next, you'll need to choose your deployment mode. This is a critical architectural decision that impacts scalability, performance, and how your data is stored and secured. Serverless mode, agility and simplicity. Serverless is designed for teams that want to move fast without managing infrastructure. Scaling, fully managed with auto-scaling right out of the box. VectorDB support defaults to Vertex AI Vector Search 2.0 and also supports providers like Pinecone and Weaviate. Cost model, fully usage-based. You pay for embeddings, storage, retrieval, and your selected vector database. There is no capacity planning required. Security note: CMEK is not supported. Data is securely handled, but runs on shared, multi-tenant infrastructure without dedicated performance isolation. Architecturally, serverless uses a decoupled retrieval model, where the RAG system interacts with a vector database as a separate managed service. Spanner mode, control and predictability. Spanner mode is designed for production workloads that require predictable performance, isolation, and compliance controls. Isolation and security provides dedicated storage and performance isolation with support for CMEK. Scaling and performance: you provision capacity through tiers using processing units, enabling predictable latency and throughput. An auto-scaling tier is also available.
VectorDB support defaults to RAG managed DB, backed by Cloud Spanner, and also supports providers like Vertex AI Vector Search 2.0, Vertex AI Vector Search 1.0, Pinecone, and Weaviate. Architecturally, this mode uses an integrated storage plus retrieval model, where vector data is tightly coupled with the underlying database. Understanding cost and behavior. The billing model depends on both the mode and the vector database you choose. Serverless, always usage-based. Vector database costs are billed separately based on your provider. Spanner mode, tier-based pricing. If you use the default RAG managed DB, vector storage and indexing are included. If you use another database, it is billed separately. Important. Switching modes is possible, but data is completely isolated between them. Data ingested in serverless mode will not be visible in spanner mode, and vice versa, so choose based on your long-term performance and security requirements.
The RAG engine supports multiple backend options for retrieval, giving you flexibility in performance, consistency, and operational control. At a high level, you're choosing between integrated storage, managed vector services, feature pipelines, or external databases. 1. The default integrated option, RAG Managed DB. This is the default vector database in spanner mode. It is fully managed by the RAG engine and backed by Cloud Spanner, making it ideal for enterprise workloads that require strong consistency and high availability, low latency performance, CMEX support for compliance. It supports exact search, KNN by default, approximate search, ANN for scalability. It also allows tiering for prototyping versus production. So in this model, vector storage and retrieval are built directly into the database layer. Note, for optimal ANN performance, index rebuilds may be required after major updates. Best suited for enterprise RAG systems, chatbots, and high reliability workloads. 2. Managed service option, Vertex AI Vector Search. Commonly used in serverless mode, this is a fully managed vector search service optimized for machine learning workloads. It provides high scalability and reliability, pay-as-you-go pricing, ANN-based retrieval, and integration with other Google Cloud services. So in this model, retrieval is handled by a separate managed service, decoupled from storage. Trade-off: updates to index data are not always immediately reflected. Best suited for large-scale, ML-driven RAG applications. 3. Feature-based option, Vertex AI Feature Store, Preview. This option is designed for ML-centric architectures, where embeddings are part of a feature pipeline. Built on BigQuery infrastructure, integrated with Vertex AI workflows, and supports ANN-based retrieval. Trade-off: updates require manual synchronization before becoming available. Best suited for teams already using feature stores in production ML systems. 4. External databases, BYODB. RAG engine supports external vector databases for maximum flexibility. Weaviate. Open source, flexible, supports hybrid search, can be self-hosted or managed. Pinecone. Fully managed, high-performance similarity search, optimized for low-latency workloads. These are ideal if you already have an existing vector database stack. Integration requires API keys via Secret Manager, endpoint and index configuration, lifecycle and scaling decisions, depending on provider. Trade-offs: updates may not be immediately reflected. Cost and performance vary by provider. 5. Search-based retrieval option, Vertex AI Search. In addition to vector databases, RAG engine can use Vertex AI Search as a retrieval backend. Uses keyword plus semantic ranking. Built for enterprise search experiences. Leverages Google quality search infrastructure. Unlike vector databases, this approach is search first, not embedding only. Best suited for document-heavy search applications, enterprise knowledge bases, scenarios where keyword relevance matters. Security and platform notes. Supported VPC service controls, CMEK with RAG managed DB. Not supported data residency, AXT security controls. Critical integration tip: backend selection is sticky. Once a corpus is tied to a database, switching typically requires re-ingesting your data. Key takeaway: you are balancing integration, scalability,
and retrieval approach. RAG Managed DB, best for consistency, isolation, and enterprise workloads. Vertex AI Vector Search, best for scalable ML-driven retrieval. Vertex AI Feature Store, best for ML feature pipelines. External databases, best for flexibility and existing ecosystems. Vertex AI Search, best for search-first retrieval experiences. The RAG engine abstracts orchestration across all of these, allowing you to focus on retrieval quality and application logic.
To achieve high precision and high relevance results, the RAG engine provides advanced retrieval capabilities that operate in two stages: filtering and ranking. 1. Metadata filtering, the precision layer. You can attach structured metadata, such as numeric, string, or Boolean fields to your documents to enable precise filtering during retrieval. Here's the rule. Metadata must be defined using a schema at the corpus level before ingestion, and all values must conform to that schema. Once configured, you can filter results using CEL, Common Expression Language, expressions. For example, metadata.department equals finance, and metadata.year greater than or equal to 2025. This ensures retrieval is restricted to the most relevant subset of documents, improving precision and reducing irrelevant matches. 2. Neural ranking, the relevance layer. Semantic retrieval alone can return contextually similar results that aren't always the most relevant. To address this, the system applies a ranking step. Vertex AI Ranking API, stateless ranking layer, optimized for fast scoring at scale, best suited for low-latency production workloads. LLM Re-Ranker, Gemini-based, uses LLM reasoning to evaluate context deeply. Higher latency but stronger semantic understanding, best for complex, ambiguous, or multi-step queries. 3. Cross-corpus retrieval, the federated layer. The RAG engine supports querying across multiple corpora in a single request using an agentic routing system. This is done through ask contexts, synchronous retrieval and response generation, and async retrieve contexts, asynchronous retrieval for large-scale workloads. Each corpus includes a description field, which is used by a Gemini-based planning agent to evaluate relevance and generate a retrieval plan. Only the most relevant corpora are selected for retrieval, enabling efficient federated search across multiple datasets. Key takeaway: metadata filtering improves precision before retrieval. Ranking improves relevance after retrieval, and cross-corpus routing enables intelligent multi-dataset search. Together, these layers ensure the RAG engine delivers highly relevant, structured, and context-rich information to the model.
Security. The RAG engine is built for the enterprise, supporting VPC service controls for network isolation. CMAC, Customer Managed Encryption Key, is supported, but only when using RAG Managed DB. Critical note: CMAC encryption key must be configured at corpus creation. It cannot be added later. Also, data residency and ATXT security controls are currently not supported. Billing, the component model. The RAG engine follows a component-based billing model. You don't pay for the RAG logic itself, you pay for the services it uses. Data ingestion. Accessing data from sources like cloud storage or drive is free, but standard data transfer or egress charges may apply. Data transformation. Parsing. Default parser, free. LLM-based parsing, billed via model usage. Document AI, billed separately. Chunking. Fixed-size chunking, free. Embeddings, retrieval, and generation. Embedding generation, billed based on the selected embedding model. Re-ranking. LLM re-ranker, model cost. Ranking APIs, API cost. Grounded generation, billed per model request. Vector storage, major cost component. If you choose RAG Managed DB, it provisions a Cloud Spanner instance. Basic tier, 100 processing units. Scaled tier starts at 1 node, 1,000 units with auto-scaling. Important: you are billed for this provisioned capacity as long as the corpus exists, regardless of usage. Other options include Vertex AI Vector Search, external databases like Pinecone or Weaviate,
These are billed based on their respective services. Summary: most of your cost comes from model usage, parsing, embeddings, generation, and vector storage and indexing. Because provisioned capacity like Spanner incurs ongoing cost, your backend choice is the biggest lever for controlling total cost of ownership. To wrap up, the Vertex AI RAG engine is a powerful system for grounding large language models in real private data. It automates the entire retrieval augmented generation pipeline, helping reduce hallucinations and improve accuracy. Whether you start with serverless mode or deploy with Spanner for enterprise requirements, the RAG engine scales with your needs. Stay tuned for the next video, where we'll walk through setting this up for production.